Okay, hello everyone, and welcome to going over the Simpsons experiments, these variables. So, we've just learned about variables and how we use the variables, how we can identify them, what makes a good test, what doesn't make a good test. We're going to now put that into practice and look at some variables using the Simpsons. So, first thing to do is please put your name on this assignment. My name is Miss Moronic. Please put your actual name and then put the due date and then the hour that you have me for science class. So what we're looking at here is I can conduct an experiment scientifically by using variables and fair testing procedures. That is a huge one. When we run a test, when we do a test in class or an experiment, we want to make sure that it's fair. Otherwise, it's not a good test. We're not able to test what we need. We also want to be able to use data gathered from an experiment to analyze the findings and come to a scientific conclusion. We can't come to a good, solid scientific conclusion if we don't have valid data or good data. We get good data by having the correct variables. As we just learned about, we only want to have one independent variable. We want to have everything else remain the same. So let's get started. First and foremost, so Smithers thinks that a special juice will increase the productivity of workers. He creates two groups of 50 workers each and assigns each group the same task, stapling a set of papers. Group A is given the special juice to drink while they work. Group B is not given the special juice. After an hour, Smithers counts how many stacks of papers each group has made. Group A has made 1,587 stacks. Group B has made 2,113 stacks. So we need to get to what is our independent variable. So remember, our independent variable is the one thing that I change, or in this case, it's the one thing that Smithers has changed. Now, when we go through this, I do ask that you have gone through and given this your best ideas first, and then you're going over this to double check to see if you have the correct information, or if you still have questions, then you can look here or watch this and then be like, oh my gosh, I need to ask Miss Moradic or Mrs. Carpolinia for a little bit more help. So what we can do is first is our independent variable. That is the one thing that I change. It starts with the letter I, so it's the one thing I change. So the thing he is changing is giving them this special juice to drink. As a result of this, what are we looking to observe? So what is depending on us changing that one thing? That one thing that or what we're looking to observe, or what we're looking to calculate or get our data from, is how many stacks of papers that are made. So then we get to our controlled variables. And what things are we going to keep the same? You could have many, many, many different options, and they all could be correct. Some things that we'd probably want to keep the same is same number of papers. He already says it in here that he's got 50 workers in each group. Which, I mean, that's a pretty good amount of people to have 50 people. It's not like he's just doing it with like 4 people. And they're stapling a set of papers. So we probably want to make sure they all have a good stapler. Because we all know that there are staplers in the world that are not the good staplers, that they work half the time and don't work half the time. And that wouldn't be fair to be like, oh, you got less stacks because you had a bad stapler. That would not make a fair test, because that would be different. We want to make sure they would all have the same working staplers, whether they're all going to be brand new, they're all going to be the same brand. We want to make sure everyone has the same opportunity with using their staples. So what is our control group? Our control group is something that is not getting anything new. So group B here is not given the special juice. So group B is not given the special juice and is the control group. So then our conclusion, well, did the juice work? So group B, no juice. Group A, juice. He wanted to see that if the special juice will increase the productivity. Group A got the juice, Group B did not get the juice. Group B clearly made more stacks of paper than Group A. So, was his special juice good? No. If anything, it made them worse. Did not. So the special juice did not make the workers more productive. If anything, Group A did worse. Okay, is this a fair test? We could say it's a fair test. There was only one thing that was changed. We are observing just the one thing, and everything, assuming that it was all these were followed, it would be a fair test. Okay, on to our next side. So, Homer notices that his shower is covered in a strange green slime. His friend Barney tells him that coconut juice will get rid of the green slime. Homer decides to check this out by spraying half the shower with coconut juice. He sprays the other half of the shower with water. After 3 days of the treatment, there is no change in the appearance of green slime on either side of the shower. So, what is our independent variable? What is the one thing that is being changed? The one thing he's changing is using this coconut juice. So what are we looking to observe? Our dependent variable. We want to see if we can get rid of this green slime. So it'd be like amount of green slime. So let's add those here. So independent variable is adding coconut juice and the amount of green slime. So what are things that we'd want to keep the same? We want to make sure that we're using the same shower. We'd probably want to use the wall that we can use half and half. Like, so I know in my bathroom, like right below the shower head is where most of the water is going to collect, but the wall on the far side is hardly going to get wet at all. We wouldn't want to use the coconut juice on the side that gets all the water and water just on the side that doesn't get much. We want to make sure we have an equally used shower. And another thing we could also check is, do we want to probably keep our daily routine the same? So if this is something he's noticed over time, we probably don't want to change our daily shower routine. So same. Now, could you have other ones than I have here? Definitely. There's a number of other ones that could be. These are the ones that are just kind of the most, hopefully, pointing out within here. So, what is our control group? Again, the control group is the one that gets nothing new. So, the one that's getting nothing new is the one that's getting water. So, part of the shower getting only water. So, what is our conclusion? After After 3 days, if we added the coconut juice, did we get rid of the green slime? After 3 days of treatment, there's no change in the appearance of the green slime on either side of the shower. So, conclusion, the coconut juice does not get rid of the green slime. Honestly, I'm a little worried as to why Homer has green slime in his shower. Instead of using coconut juice, I might just clean the shower. But that's just me, you know? Everyone's a little bit different. So, our last one, Krusty was told that a new itching powder called Scratchy was the best on the market. It even claims to cause 50% longer lasting itches. Interested in this product, Krusty buys the itching powder and compares it to his usual product, Itchy. One test subject A is sprinkled with the original itching powder, Itchy, and another is sprinkled with the experimental itching powder, Scratchy. Subject A reported having itches for 30 minutes. Subject B reported having itches for 45 minutes. Okay, let's make some sense of this. So, what is the one thing we're changing? The one thing we're changing is the new itching powder. So, what are we looking to observe? Our dependent variable is how long the itches last. So, I'm going to highlight this part, length of itching. Okay, so what are some things we'd want to keep the same? Well, if we're going to sprinkle this into people's pants, which sounds kind of horrible, we probably want to use the same amount. We might want the test subjects to wear the same pants or same brand or type of pants. And another thing, we might want to do it at the same time. So it's not like a really warm day one day, but a really cool day another, or a humid day one day or another. So done on same day at the same time. Now, again, could you have other ones? Definitely. And you could totally be correct. These are just some to get us started. So, our control group, there's a lot going on in here. And sometimes when there's a lot going on, I like to just kind of map it out. So, we have subject A. So, we've got A is the one that gets the new powder, B gets the old or the same one. And let's see. So, subject A has itches for 30 minutes. And subject B has 45 minutes. And he was told the new itching powder claims to last 50% longer. So letter A should have longer scratches, or itches rather. Okay, so our control group. Our control group is the one that got nothing new. So group B, or rather, it was person B, got the usual itching powder. So then our conclusion. Well, did the new itching powder last 50% longer? Well, if group B had itches for 45 minutes and group A had it for only 30 minutes, group A had less, like the itches lasted less time. So, is this good? No, they did not last longer. So, conclusion, the new itching powder does not last longer. Group B had itches that lasted longer, about 50% longer, but it's not quite. So, is the claim or product accurate? No, because the itches didn't last longer. Something I would also bring up in this, Krusty used one person for each of these tests, and it was a different person. Would that really be a fair test? Probably not. When we had Smithers, he had 50 in each group. That's a pretty good sample size. Homer, he only did it over 3 days, but at least he did have the same wall 3 days. Maybe he should have gone a little bit longer, but I mean, it's not the worst test in the world. But to only have one for each type of each product and to have two different people try it, it's not really a fair test at all. So that's where we end up with the Simpsons variables. Please let your teacher know if you do have any questions. Otherwise, we're going to keep on going. We have a lab coming up, and we're going to need to know about variables. We're going to be learning about data tables and graphs, and we'll need to know about data tables or variables because that's how we know where to put our different information and our data onto our data table and graph. So make sure you know this information. If you have a question, let your teacher know. Otherwise, have a great day. Bye.